coordinate is 0, it's going to be x-intercept, also called zeros. So the first one is already factored for you. So you just have to find the zeros that go with that. Two of them should be very simple. One of them is just a little teensy bit tricky. What do you do with that 2x plus 3? What are you going to get? Set equal to 0. So you'll have 2x plus 3 equals 0. You'll subtract that 3. 2x will equal negative 3 and divide by 2. So x equals negative 3 halves is one of those zeros. Or if you want to do negative 1.5, either one is fine. And then essentially you're doing the same thing with the others, but the others we usually just go ahead and write down x equals negative 2. And then we'll have x minus 1 equals 0. So that's x equals 1. So those are our zeros for g of x. Everybody good there? All right, 2. What have we got to do differently on that one? We got to factor because it is not factored. What is the first thing we're going to have to do to factor that? Take an x out. Perfect. So we got h of x equals x times x squared plus 3x minus 4. And so that second part, x squared plus 3x minus 4, we would factor that into x times x, and then we'd have a positive 4, negative 1 for that. And so you're going to get x equals 0, x equals negative 4, and x equals positive 1 for that. Yes?
For the, 4 and negative 1, is it, I have to get the first number and multiply it with the second?
Yes. Yeah, that middle number is what they add to. Last number is what they multiply. Yeah. Okay, questions? Okay, B is a little trickier. It is asking you to do something different, and it is going to have more difficult factoring on there. So, for this is asking us to tell when k of x is greater than 0. If this was calculator active, we could graph it and see where it's above the x-axis. It is not calculator active. So, we need to think about where 3x squared minus 19x minus 14 is greater than 0. And so this is one of those inequalities, a polynomial inequality. These are the problems where we had to make that chart and tell whether it was positive or negative, right? So before we do the chart, what's the first thing that you have to do? We got factors, so we can find those zeros, right? Is there a greatest common factor on this? Kind of like divide everything by 3 or take out x? No. So this is going to be different factoring than up here. This 3 right here makes it more difficult because I still need to be able to multiply to get negative 14. But the only things I can multiply to get negative 14 are negative 7 and 2, or negative 1 and 14, or if I want to, I could list the sign switched on that. Do either one of those give me negative 19? They do not. Okay? They are not going to because of this 3 right here. Okay? So for these, you technically can do the X method. Did some of you guys do the X method with Miss Martin maybe for factoring where you do like the X? I personally hate it. It does work. To me, it is a trick for factoring that helps kids that are weak. I like for you guys to not need it. However, if you use the X method every time and you're really good at it, and I just need you to be able to factor this. I don't really care how you do it. If you love the X method, go ahead and use it. What I don't like about the X method on this one is you got to do 3 times negative 14. And that gets to be a fairly big number. And I don't know my multiplication tables up to numbers that big. And then I don't like doing it. So if you want to use the X method, please go ahead. I think that with students who struggle to factor, it's a great tool to use. I want you guys to be students who do not struggle to factor and don't need it anymore. It's not bad to introduce, but you don't need it anymore. So I don't usually do X method, but it is an option if you like it. What I do is that first term is 3x squared. What could I multiply together to get 3x squared? 3x and x. So what I need to happen here is my first terms have to multiply to give me 3x squared. That means I'm going to have to put 3x right here and an x right here. All right. And then the last terms need to be one of these options right here. I'm going to have to guess and check to see if it's right. Now, when you get better at this, like I usually do this part in my head unless the numbers are getting really big and I'm needing to visualize it a little bit, but I can like visually put these here and see what's going to happen. But unless you're pretty good at that already, you probably want to actually write it down and check it. So like let's just put a -7, +2 here. I usually use the numbers closer together. They tend to be the answer more often than not, but they're not always. So to check this, you just multiply it back. So if I want to multiply it back, let's use some different colors here. 3x times x, it's supposed to be x right there, is going to give me 3x squared. I know that one should work because that's why I picked 3x and x, right? If you won't, you don't even have to check that one because that's why you picked 3x and x. Then the ones that really become important are these middle ones. I've got to do 3x times +2, which is going to give me a +6x. I've got to do -7 times x, which will give me a -7x. And then this last one here, where I do -7 times +2, I really don't even have to check that one either, because that's why I picked -7 and 2, because I knew it would give me -14. All right, so what I'm really looking for is I need to see if this gives me the correct middle term. Does it? It does not, right? +6 minus 7x is going to give me a -x. I want to have a -19x, so this does not work. So, and you know, as you get better, you might can check it in your head, but right now, you may or may not be able to do that. So, since that did not work, that means if you get the opposite sign, you can just switch signs, but we don't have opposite signs here. Before you give up on 7 and 2, try switching where they're at. It makes a difference on these problems. On a problem that has an x squared, it makes no difference which one comes first. It does on these. So let's try a +2 right here and a -7 right here. So if I do that, 3x times x is still 3x squared. 3x times -7, let me erase this middle part right here. Well, I do 3x times -7, I get -21x. And then for that middle part, the 2 times x, I'll get +2x. So I'm looking to see here if this gives me -19x. Does it? Yes, so that means I've factored correctly. That means that my problem is 3x plus 2 times x minus 7 is greater than 0. Yes. Yeah. If I end up with like the opposite sign, then I just switch those two there. So whenever we're doing these problems, we now need to get the zeros that go with this. 3x plus 2, what's the 0 that goes with that? Almost -2/3. And if you need to, write that over to the side. 3x plus 2 equals 0. So you have to subtract the 2. 3x equals -2 divided by 3 to get that -2/3. What's the 0 that goes with x minus 7? It's just +7. So you're going to put those on. If you like the chart, you're going to put these on number line. -2/3, 7. And then I'm just going to take each one of these factors here and put them on the side. 3x plus 2 and x minus 7, and a line for my answer there. So this. And so you're just thinking about plugging in numbers to each section. If I plug in a number like -1, that would fall down in this category. 3 times -1 plus 2, that's going to give me a negative number. But then, anything bigger than -2/3, like if I plug in 0, is going to give me a positive number. And then, obviously, anything bigger than 7, also positive there. As long as it's a linear term, you should just see it switch one time. And then the x minus 7, if I plug in something like -1, I'm going to get a negative there. Same thing here in the middle. I'll still get a negative. But if I plug in a number bigger than 7, I'm going to get a positive. So when I'm doing that answer line right there, I've got negative times negative will give me a positive here. This will give me a negative in the middle, positive here on the end. Which ones are going to be our answers, the positives or the negatives? Positives, because we are looking at greater than 0, so that's our positives. So that's this section and this section. You can say either x is less than -2/3 or x is greater than 7, or your other option, -infinity to -2/3 and 7 to infinity. Everybody get there? Okay, let's look at this last one. This last one is really like the question they asked us in part A, but in reverse, and they throw in some non-real zeros, which makes it a little tougher. But it's really just asked in reverse. So, for example, right here, if I have x equals 0 as a 0, I had x as a factor, right? If I have x equals -4 as a 0, I had x plus 4 as a factor. If I have x equals +1, I have x minus 1 as a factor. So what they've done is they've given us the zeros, and we have to go back to the equation. So they told us x equals 0. They told us x equals 5. They told us x equals 3 minus 2i. Now, it tells us it's a degree 4, which means I should have 4 zeros. I'm missing one. What is that last one going to be? Very good. Because our non-real zeros always come in pairs. You have the conjugate pair, so you're going to change that sign right there. So, if I have x equals 0 as a 0, that means I'm going to have an x, or if you want, you can even put x minus 0 there as my factor. And then if I've got x equals 5, I've got an x minus 5. And then same thing is going to hold true even with these non-real answers. So if I've got 3 minus 2i, I'm going to have x minus 3 minus 2i. And 3 plus 2i, I'm going to have x minus 3 plus 2i. Notice that I put an extra set of parentheses there because you're subtracting that whole thing. However, if I decided that I wanted to distribute that negative, I could. And if I put this as an answer, x minus 3 plus 2i, and distribute here, x minus 3 minus 2i, like that, that would be okay too. They should take either one of those answers, I believe. Does that make sense? Okay, we barely have time. Let's because I know it's going to take you 3 or 4 minutes to get your computer out and start on the progress check. In which case it's going to be time to pack up and go. Let's do this. Let's go